This is a group project presentation for CS410 text information system. My name is Zhu Chao, and the topic of our group project is a semantics search tool for Stack Overflow answers. So we have Gamin and myself working on this project with Gamin as the overall project coordinator. What we have built is a semantic search engine for Python-related Stack Overflow answers. It will retrieve top 100 Stack Overflow answers based on the following criteria. First, semantic similarity. Secondly, voting. Lastly, the sentiments of the comments. We used Flask framework to build one web application and host it on a GCP virtual machine instance. And this is the URL. We are going to explore it later. So the data we have used is from one of the public dataset on BigQuery, and the link is here. Step 1 is to pre-process the data. First of all, we extracted the body answer, votes, comments, as well as the URL from the data. Then we use BigQuery to get a table stored on Google Cloud Storage, and from there we export the CSV file for our data cleaning, transformation, and manipulation. Second step is data cleaning and transformation. First of all, we scope the problem down to Python by filtering out the solutions with a Python tag. Secondly, we have removed the code block in each post since it's not always correct and complete, and for most of the time doesn't have any semantic meaning. Then we constructed the URLs for each post such that the users can refer back to those answers, original answers. Lastly, we use the text block library to calculate the common sentiments for our ranking. The next step is to train the model. So, with particular domain, we decided to train our own model to generate embeddings. With the data pre-processed from last step, we used one unsupervised learning approach, and we have generated around 500 feature dimensions and feed it to the LSTM model. To rank the results, we have used a tangent H function to process the votes to scale it to -1 to 1 and penalize on the extreme values. And we also normalized the sentiments before we use it. We use the NMS line to build index and retrieve index with cosine similarity. So eventually, we use this formula to get the ranking scores for all the answers. And this formula consists of the cosine distance and the faults and the normalized sentiments. So we use the Jupyter Notebook for this project, and this is the URL for the Jupyter Notebook. For hardware or infrastructure, we deploy one virtual machine instance consisting of 16 CPUs, over 100 GB memory, and 100 GB disk space, with a pre-built Docker imaging to train our language model. So this is the code structure. So we have notebook requirements and setups, virtual machine setup, and web apps. So basically, notebooks consist of the data processing, model building, and the ranking, while the web application consists of the user interface. So let's explore the application. So I'm going to open this URL. Then let's do a search. For example, let's do a data frame merge. So you can see it has returned a list of answers. So for each answer, it consists of 3 parts. The first part is the first couple of text from the answer body. The second part is the ranking score for this answer. The last one is the URL linking to this answer, so we can refer back to the original content of the answer. So next, for example, goes back to the answer. So you can see we have got the original answer. If we scroll down, so we can see we have all those answers based on the listed down based on the ranking scores. So that's all we have. Let's try to use another search. Let's try read data into data frame. Okay, so here's the list of results. Okay, it looks like this one is quite relevant. Let's check it. This one as well. Okay, this one. Okay, so this result is quite relevant. So it says this is a method to read a CSV file into a pandas data frame. And this is another one. So basically, we use pandas read CSV to read a file to pandas data frame. And this answer is also quite relevant.